Our Milky Way Galaxy, a majestic spiral of stars, gas, and dust, stretches across a staggering 100,000 light-years. Within its swirling arms, billions upon billions of stars shine, each a distant sun, potentially harboring its own planetary systems. This vast collection of celestial objects has captivated humanity for millennia, inspiring awe, wonder, and countless questions about our place in the cosmos. One question that often arises is deceptively simple. How many stars reside within our galaxy? While we can gaze upon the Milky Way and be awestruck by its countless points of light, determining the exact number of stars within this celestial structure proves to be a surprisingly complex endeavor. Astronomers estimate that the Milky Way contains between 100 and 400 billion stars. This vast range highlights the inherent challenges in conducting a cosmic census. Imagine trying to count every grain of sand on a beach. The task is daunting, and scaling it up to the galactic level only amplifies the difficulty. The Milky Way's structure, a barred spiral with multiple arms, adds to the complexity. Stars are not uniformly distributed. They cluster in dense regions within the spiral arms and thin out in the vast spaces between. This uneven distribution makes it challenging to extrapolate the total number of stars from observations of limited regions. Our view of the Milky Way is further complicated by the presence of interstellar dust and gas, which absorb and scatter starlight, particularly at visible wavelengths. This obscuring material acts like a cosmic fog, veiling distant stars and making it difficult to obtain a clear picture of the galaxy's structure. To overcome this obstacle, astronomers rely on observations at longer wavelengths, such as infrared and radio, which can penetrate the dust and gas. These wavelengths provide a clearer view of the galactic center and other regions heavily obscured at visible wavelengths. Now, let's consider another vast number: the estimated total of all humans who have ever lived on Earth. While seemingly immense, this number, estimated to be around 100 billion, pales in comparison to the estimated number of stars in the Milky Way. Even at the lower end of the estimate, the Milky Way likely contains at least as many stars as there have been humans throughout history. This comparison underscores the sheer scale of the cosmos and our relatively small place within it. Section 5. Beyond our eyesight, beyond our instruments. The challenges of counting stars extend beyond obscuring dust and vast distances. Many stars are simply too faint to be detected by even our most powerful telescopes. These faint stars, while individually insignificant, likely contribute significantly to the Milky Way's total stellar population. Additionally, the Milky Way is a dynamic and ever-evolving structure. New stars are constantly forming within vast clouds of gas and dust, while older stars reach the end of their lives, some ending in spectacular supernova explosions. This continuous cycle of stellar birth and death adds another layer of complexity to the task of counting stars. Section 6. Stellar nurseries and galactic graveyards. Within the Milky Way's spiral arms lie vast molecular clouds, cold and dense regions where stars are born. These stellar nurseries, often obscured by the very dust and gas from which stars form, provide a glimpse into the ongoing process of star formation. As stars age and exhaust their nuclear fuel, they eventually die. Some stars, depending on their mass, end their lives in dramatic supernova explosions, briefly outshining entire galaxies. These stellar remnants, along with less dramatic stellar corpses like white dwarfs and neutron stars, contribute to the diverse stellar population of the Milky Way. Section 7. A universe of scales, making sense of the immense. To grasp the enormity of the Milky Way and its stellar population, it's helpful to employ comparisons that bring these cosmic scales down to Earth. The Milky Way, our home galaxy, is a vast collection of stars, planets, and other celestial objects, all bound together by gravity. Imagine shrinking the Sun, a star with a diameter of 1.4 million kilometers, down to the size of a grapefruit. This simple analogy helps us visualize the otherwise incomprehensible size of our star. On this scale, the Earth would be a mere peppercorn orbiting the grapefruit at a distance of about 15 meters. This comparison makes it easier to understand the relative sizes and distances in our solar system. Now imagine placing another grapefruit, representing our nearest stellar neighbor, Proxima Centauri, at a distance of about 4,000 kilometers away, roughly the distance across the continental United States. This helps us appreciate the vastness of space even within our immediate stellar neighborhood. This vast distance between even the closest stars highlights the emptiness of space and the immense scales involved in galactic astronomy. The sheer emptiness and the enormous distances between stars are a testament to the vastness of our universe. Understanding these scales is crucial for comprehending the true nature of our cosmic environment. Section 8. The Cosmic Census. Methods and Challenges. Astronomers employ various methods to estimate the number of stars in the Milky Way. These methods are crucial for understanding the structure and evolution of our galaxy. One approach involves measuring the galaxy's total mass and then estimating the proportion of that mass accounted for by stars. This requires precise measurements and sophisticated models to ensure accuracy. This method, however, relies on assumptions about the distribution of dark matter, a mysterious substance that makes up a significant portion of the Milky Way's mass, but does not emit light. Dark matter's elusive nature adds complexity to these calculations. Another method involves counting stars in a small representative region of the Milky Way and then extrapolating that number to the entire galaxy. This technique can provide valuable insights, but also has its limitations. This approach, while more direct, is susceptible to biases introduced by the selection of the representative region and the challenges of observing faint or obscured stars. Factors such as interstellar dust and varying star densities can affect the accuracy of these counts. Despite these challenges, astronomers continue to refine their methods, combining data from multiple sources to improve their estimates and deepen our understanding of the Milky Way. Section 9. Beyond the Milky Way, a universe of galaxies. The Milky Way, while vast, is but one of billions of galaxies that populate the observable universe. These galaxies come in various shapes and sizes, from majestic spirals like our own to massive elliptical galaxies containing trillions of stars. The sheer number of galaxies, estimated to be in the trillions, further underscores the vastness of the cosmos and the staggering number of stars it contains. Our Milky Way, with its hundreds of billions of stars, is but a single grain of sand on a cosmic beach of unimaginable scale. Section 10. The ever-evolving cosmos, a dance of birth and death. The universe is not a static entity. It is a dynamic and ever-evolving system. Galaxies collide and merge, triggering bursts of star formation. Stars are born within vast clouds of gas and dust, live their lives fusing hydrogen into helium, and eventually die, some ending in spectacular supernova explosions that seed the interstellar medium with heavy elements. This continuous cycle of stellar birth, life, and death ensures that the cosmic dance continues, with new generations of stars forming from the ashes of their predecessors. The Milky Way, like all galaxies, is a snapshot of this ongoing cosmic evolution, a testament to the dynamic nature of the universe. Section 11. The Enduring Mystery. Despite our best efforts, the exact number of stars in the Milky Way remains an elusive figure. Astronomers have spent countless nights peering through telescopes, mapping the heavens, and yet, the true number of stars continues to evade us. The challenges of obscured views, vast distances, and faint stars, coupled with the dynamic nature of the galaxy itself, make a precise count an insurmountable task. Dark clouds of interstellar dust and gas often hide many stars from our view, adding to the complexity. Yet, this inability to quantify the Milky Way's stellar population does not diminish the wonder and awe it inspires. Each star, whether visible or hidden, contributes to the galaxy's majestic beauty and the sense of mystery that surrounds it. The Milky Way, with its countless stars, serves as a constant reminder of the vastness of the cosmos and the enduring mysteries it holds. It stretches across the night sky, a river of light that has fascinated humanity for millennia. As we continue to explore the universe and refine our understanding of its workings, we can be certain that the Milky Way will continue to captivate and inspire generations to come. Its mysteries drive us to look deeper, to question, and to seek answers in the vast expanse of space.